UV light. You might know it as the stuff that causes sunburns, but in fact, it plays a key role in making life possible. UV light is the range of light just beyond human vision. Even though we can't see it, UV light from the sun has fundamentally shaped the planet we live on. Could it be a key to finding other planets capable of supporting life? I know some rocket scientists who think so. We're here in Australia, and we're gonna launch some rockets. We're following 2 NASA rocket missions as they try to understand how stars make the planets around them suitable for life. I'm Miles Hatfield, and in this episode, we're exploring how ultraviolet light can make or break a planet's ability to support life.
When we look for planets around other stars and try to assess, is that a place where life exists, we're almost always talking about, does that atmosphere have the signs of life in it? And so that means things on Earth like, do we have molecular oxygen? Does it have ozone? Does it have methane in the atmosphere?
These special gases are what scientists call biomarkers, the traces of life we leave behind on our planet. But, Kevin told me, what counts as a biomarker on Earth might not for a planet orbiting a different kind of star. A lot of it depends on how much UV light the star emits, or what scientists call its UV flux.
There are kind of 2 big things that UV light does to a planet's atmosphere. One, it drives photochemistry in the atmosphere. So Earth's atmosphere is a combination of things that happen photochemically and things that happen biologically and then float up.
Our ozone layer is a great example. About 2.5 billion years ago, bacteria in Earth's ancient oceans had just become the first photosynthesizers. In other words, as those little guys broke wind, Earth's atmosphere started filling up with oxygen. Don't think too hard.
Atmospheric escape, and that's kind of as simple as it sounds. If the star has enough ultraviolet flux, it heats up the atmosphere, and if the atmosphere gets hot enough, that atmosphere will become gravitationally unbound to the planet and escape.
Believe it or not, this happened on Earth too. About 4.5 billion years ago, when Earth was just a wee baby planet, its original atmosphere was mostly made of hydrogen and helium. That atmosphere was blown off into space, paving the way for the livable, breathable atmosphere we know today.
One of the things we've learned in the last couple of years is the sun is atypical in that it's about 5 times less magnetically active than typical stars of its age. And magnetic activity is what drives the ultraviolet flux. So just because we have great data on the sun, it doesn't mean that we can take that data and apply it broadly to any type of star like the sun out beyond.
That's why Kevin and his team are looking at Alpha Centauri, our closest stellar neighbors. This 3-star system is a little more than 4 light years away. Kevin and his team are focusing on the larger, sun-like stars, Alpha Centauri A and B. They're our best chance to measure UV light from sun-like stars that aren't, well, our sun. But Sistine can't do it alone. Another rocket mission is set to launch right after Sistine and would capture wavelengths of UV light too hot for Sistine to handle, so to speak. And members of team number 2, fittingly named Deuce, had just arrived. I'd heard they could be found somewhere around here, probably hiding away, hoping to get some work done before we started shoving cameras in their faces. Nice try. Hey, Emily.
Hey.
Your team, Deuce and Sistine, are both measuring ultraviolet light. So what's the difference between the things you're measuring? What are you studying differently?
So Deuce measures the extreme ultraviolet, which is a very energetic form of light, and Sistine is measuring far ultraviolet light, so a little bit less energetic, longer wavelengths, and we have a little overlap in our spectrum so that we can actually have a much broader spectrum than either of us would get alone.
I see.
Yeah.
Okay, so like overlap to just check that, like, okay, I'm seeing the same thing in that region of overlap as you are, and then we can calibrate together.
Exactly.
Got
exactly.
it. I see. Launching a few days apart, Deuce and Sistine will work together like one super mission. The end goal goes beyond Alpha Centauri, and even sun-like stars, to an understanding of star-planet systems in general.
Alpha Centauri is the closest star system to Earth, other than the Sun, and has in its triple stars one that's a sun-like star, so we can use that star to see what other stars that might have planets around it look like.
What is your role during launch? What are you going to be doing?
So I will be steering the payload.
You are pointing the telescope
Yes.
and making sure it's
Yes.
aligned on the star.
Yeah.
Wow. Yeah, that's a big job.
Yeah.
Next time, as we prepare for launch, a look behind the scenes at the space vehicles that will get us there. Vroom vroom.